Okay, G. Complex number, lecture number 2. Now you have four different roots that are given in form of Z1, Z2, Z3, Z4. We'll be working on addition and subtraction of the complex number. Let's just do a few examples. Let's say adding up Z1 plus Z2. So 2 plus 3 iota plus minus 1 plus 2 iota. So this will be 2 minus 1 plus 3 iota plus 2 iota. So the end result we will have is 1 plus 5 iota. Let's do another example of this. Z1 plus Z3. Now Z1 is 2 plus 3 iota and plus Z3 is minus 4 minus iota. So if we just solve this thing down, we'll write this thing as 2 minus 4 plus 3 iota minus iota. So this should be minus 2 plus 2 iota. Z1 plus Z4. So Z1 we know that is 2 plus 3 iota and Z4 was 1 minus 3 iota. So plus 1 minus 3 iota. So this thing will be 2 plus 1 plus 3 iota minus 3 iota, which is cancelled out. So this should be 3. Considering the same values, now we are doing Z2 minus Z1 minus 1 plus 2 iota minus 4 minus iota. This will be minus 1 plus 4 plus 2 iota plus iota, which means minus 1 plus 4 is 3 plus 3 iota. If we have Z2 minus Z4, Z2 is minus 1 plus 2 iota minus Z4 is 1 minus 3 iota. So this thing will be minus 1 minus 1 plus 2 iota plus 3 iota. This will be written as minus 2 plus 5 iota. Similarly, if we just write down Z4 minus Z1, so 1 minus 3 iota minus 2 plus 3 iota, this will be 1 minus 2 minus 3 minus 3 iota. Minus 3 iota minus 3 iota, which will be minus 1 minus 6 iota. So that means Z4 minus Z1 will be minus 1 minus 6 iota. Now these examples are from the addition and subtraction of the complex number. When the two roots are given, you will be asked to add or subtract the roots or the values of Z. Z1 into Z2, multiplication of the complex numbers. Let's just work on the same values. Your Z1 was 2 plus 3 iota, Z2 was minus 1 plus 2 iota. So let's just write down these values here. 2 plus 3 iota multiply with minus 1 plus 2 iota. So when we solve this, we will have minus 2 plus 4 iota minus 3 iota, and we will have plus 6 iota square. Minus 2 plus iota plus 6 iota square will change to minus 1. Minus 2 plus iota minus 6. So the end result is minus 8 plus iota. So when you multiply the two roots, you will eventually end up having the Cartesian form of the complex numbers. Let's just multiply. Let's just multiply Z3 into Z4. Looking at the data again, Z3 is minus 4 minus 1, and Z4 is 1 minus 3 iota. So minus 4 minus iota multiplied by 1 minus 3 iota. If we just solve this thing down, this should be minus 4 plus 12 iota minus iota plus 3 iota square. So minus 4, we will have plus 11 iota plus 3 minus 1. Minus 4 minus 3 plus 11 iota, which will be minus 7 plus 11 iota. Let's just work out with another example. Let's say Z4 multiplied by Z1. Now your Z4 and Z1. Z4 is 1 minus 3 iota, Z1 is 2 plus 3 iota. So let's just write down 1 minus 3 iota multiply by 1 minus 3 iota multiply by 2 plus 3 iota. So the answer for this will be 2 plus 3 iota minus 6 iota minus 9 iota square. 2 minus 3 iota minus 9 minus 1. So minus 9 plus, so this should be 11 minus 3 iota. So these are a few examples of multiplication of the complex numbers with the same roots that we use for addition and subtraction. Okay, moving forward to division of the complex number, writing down the roots, same roots again. Z1 is 2 plus 3 iota, Z2 is minus 1 plus 2 iota, Z3 is minus 4 minus iota, Z4 is 1 minus 3 iota. Now, if we divide, let's say we have 2 upon iota. Now, considering we have 2 upon iota, remember this, that iota in denominator is not shown in the solution. So to remove iota from the denominator, we introduce iota in the numerator and iota in the denominator. So when the iota in the numerator and iota in the denominators are introduced, then we get 2 iota upon iota square, which means 2 iota upon negative 1. So the end result will be negative 2 iota, which will be the answer for 2 upon iota. Similarly, if we have negative 3 upon 4 iota. So to remove this, what we do is we introduce 4 iota in the numerator and 4 iota in the denominator. So what we get is minus 12 iota upon 16 iota square, which is minus 12 upon negative 16. This will be your iota. Negative negative is cancelled. So the end result is 3 upon 4 iota. So to remove the iota, what you do is you rationalize the particular value. You can directly rationalize the iota as well, since you need to finish the iota. But to make sure that we use the solution, we try to pick the entire denominator. But you can always pick the iota as well. But when we have division of the roots from the complex number, let's say Z1 divided by Z2. Your Z1 is 2 plus 3 iota and Z2 is minus 1 plus 2 iota. So this is 2 plus 3 iota upon minus 1 plus 2 iota. Now, since we know that there is iota in the denominator, we rationalize. And when we rationalize, we change the sign of the second value, not the first value. So the denominator sign will be changed. So if we write this and we rationalize, there should be 2 plus 3 iota upon negative 1 plus 2 iota. When we rationalize this whole denominator, we'll write down this as negative 1, negative 2 iota upon negative 1, negative 2 iota. That means the entire denominator will be written down in the numerator and the denominator, but we'll rationalize it with the change in sign. And then we'll make sure that we multiply. But remember this, in the denominator, if you see this negative and negative is same, but the sign of the second value is changed. So in the denominator, we can use a square minus b square. That means we can write this thing down as negative 1 square minus negative 2 iota square, positive 2 iota square, because negative is taken outside the bracket. Now, considering this, we will always multiply the numerator with all the values. That means 2 into minus 1 is minus 2. 2 into minus 2 iota will be 4 iota, 4 iota. That means it should be minus 3 iota and minus 6 iota square. When we further solve this, we should understand that minus 6 iota square will be negative and negative 1, which means plus 6 will be taken into consideration. When plus 6 is taken into consideration, minus 2 plus 6 will be 4. Whereas minus 4 iota minus 3 iota will be minus 7 iota upon. Remember this, that we have negative 1 square, which will be taken as what? Positive 1. Now in the denominator, we have negative 2 iota square. So this should be negative 4 iota square, negative 4, negative 1, which will means positive 4 will be the answer for this. So that means in the end, what we'll be looking forward for is 1 plus 4. So the end result for this will be 4 upon 5 minus 7 upon 5 iota. Remember this, let's just work down this thing again. This should be positive 1, negative 4 iota square. Positive 1, negative 4, negative 1. Negative thing is positive, so positive 1, positive 4 is 5. And 5 in the denominator will be taken into consideration. So whenever you are solving the division of two different roots, you will be using the rationalization method, and then you will be multiplying with the normal division root, so that your end root that will come will be in the form of real value of z plus imaginary value of z, which is your Cartesian form. Okay, here's another example. Let's just solve this. Minus 4 minus iota upon 1 minus 3 iota. We rationalize this. 1 plus 3 iota upon 1 plus 3 iota. Now in the denominator, what we can see is this is 1 square minus 3 iota square, right? And this should be minus 4 minus iota multiplied by 1 plus 3 iota in the numerator. When we solve this, we will have minus 4 minus 12 iota minus iota minus 3 iota square upon 1 minus minus 3, and which is 9. Let's just correct this thing down. This will be 9 iota square. So 1 minus 9 iota square. So this should be minus 4 minus 13 iota plus 3 upon 1 plus 9, which means we will end up having negative 1, negative 13 upon 10. But we will always write this thing down as real value of z and imaginary value of z. So the answer for this will be, for real value is minus 1 upon 10. For imaginary value, it is minus 13 upon 10 iota.